Hi friends, this is my room, and today I am going to show you how to create and how to implement amplitude modulation in MATLAB. Okay, so before that let me give you some basics you might be knowing, but it won't take much time. Okay, so this is the message signal generally looks like. Okay, Vm equal to Vm sine 2 pi f t. Okay, and this is a carrier signal Vc equal to Vc sine 2 pi fct, and we have to modulate it like this. And that fc carrier frequency is greater than the modulating frequency, this one. Okay, so the modulated signal will be like this: carrier amplitude is added with the instantaneous value of the modulating signal, and they are oscillated in the sinusoidally in the frequency of the carrier wave. Okay, like this. So this is amplitude modulation, and we'll also derive a result based on this amplitude. Okay, so this is amplitude. Let me crop it for you. So this is not the cropped version, and you can check the maximum value for this amplitude. This sine value can be maximum as 1 and minimum minus 1. So its value can be from Vc plus Vm and minimum value Vc minus Vm. So those will be the peak, maximum value of the peak and minimum value of the peak, not the maximum and minimum value actually. Okay, this Vm again. Okay, so you can check that Vm will be equal to maximum value of the peak minus minimum value of the peak by 2. Now we will check all these in MATLAB. So let's go to MATLAB. So firstly I will write f equal to 0.01, t equal to 1 to 400, and then this x equal to 2 pi ft. This might not be visible to you, so I am showing you in Paint the screenshot that I have already taken. So this I wrote till now. Okay, so I have taken the modulating signals frequency as 0.01, and time, this is the discrete time. I am varying from 1 to 400, and this will be the plot of the modulating signal. So amplitude is 1 for this, and it will be 2 pi ft. Okay, if this is t in this. Okay, now we plot it. So this is the plot. You can see 4 oscillations are here, as we have taken time from 1 to 400, and the frequency is f, that is normalized frequency, is 0.01. so 0.01 cycles per sample. It means for 400 samples it will be 4 cycles. As you can see here, 400 samples we have taken. We have varied t from 1 to 0 to 400. Okay, so 4 cycles. Now we draw the carrier signal. Okay, for carrier signal we represent let's take amplitude as 4. Okay, and we represent the signal as y, and I'm plotting this y. Oh, sorry, f I didn't vary it. F should be, f I'm making 0.1. Okay, so it is 10 times of the modulating signals frequency, and this is the result. So 10 times means number of cycles will be also 10 times in that same time. That is, there it was 4 cycles, and here we have 40 cycles. Okay, so again I'm showing you, zooming what I wrote just now. Okay, so this I wrote it again: f equal to 0.1 carrier frequency, t equal to 1 to 400, and this y as 4 sine 2 pi ft. I have plotted it. Okay, you've seen the result. Now I'm plotting the modulated signal. And this is the result. You might have seen similar kind of result in books also, and this is the same. So let me show you something what I did. See, for modulated signal, the formula is same. Sorry, not this one. This will be 4. Okay, I have taken this wrong screenshot. Earlier I used 3, so this will be 4. You can correct it. And 4 plus sine 2 pi, this f, this is the carrier frequency, modulating signals frequency 0.01 into t. And here I have not multiplied directly as using asterisk. I have used dot asterisk. What this dot asterisk does is that we have to multiply the corresponding element. In matrix, all variables are like in MATLAB, all variables are like matrix. So normal multiplication will do matrix multiplication, and here since the dimensions are not according to the matrix multiplication, so it will give an error. And even if you change some the dimensions, it will not give the desired result. We have to multiply the corresponding elements. So I have used this dot matrix operator. Okay, so it will multiply, like if suppose you have two matrix A and B, then A11 will be multiplied with B11 to give the result C11. Okay, so first element will be just multiplication of A11 and B11. Similarly, second element will be multiplication of A12 and B12. Okay, so that's why I have used this dot asterisk, and this will be the formula. Okay, 0.1 for the carrier frequency. Okay, now let's find out the final result. So we have this plot. I'm taking the screenshot. So here we can see, let me show you, this, the maximum value of the peak is 5 and minimum value of the peak is 3. Okay, minimum value, actual minimum value is this, but we are not interested in that. We are interested in minimum value of the peak only. Okay, so maximum value of the peak minus minimum value of the peak by 2. That was the formula I had shown you earlier, and the result will be 1. That is this one, the amplitude that we had taken for this modulating signal. So hence we got our result, and thank you for watching my video.